Hi, welcome back. So as of this point in our study of magnetic fields, we've only been considering how static magnetic fields behave in free space. So we had that permeability of free space. And now we're going to consider magnetic fields in materials, and not only to just free space, and how do our calculations change when the magnetic fields are in materials. And so what you're going to see is again a dual nature between what we did for electric fields and what we're going to do for magnetic fields. In electric fields we had the permittivity of free space and the permittivity of the material, the relative permittivity. And so we're going to do something similar where we're going to just change our calculations a little bit, where we will, instead of using the permeability of free space, we're going to introduce a relative permeability, which has to do with the magnetic material, and then we're going to change our definition of the magnetic flux density just slightly to incorporate the magnetization of the material and the relative permeability of the material. And we're also going to derive Snell's law of refraction for static magnetic flux, right? And we're going to cover inductance and inductors, just like we covered capacitors and capacitances for electric fields. And inductors are another very important circuit element as you studied in circuit analysis. And so again, regarding this duality, you're going to see we're going to talk about magnetization, and that is analogous to polarization for electric fields. We're going to talk about relative permeability, which is analogous to relative permittivity for electric fields. We're going to talk about magnetic energy, where we talked also about electric energy, and we're going to talk about inductance, like we talked about capacitance. Now, so there's this duality. It's exactly one to one. For every electrical concept, there's a magnetic concept as well. And what's really cool, and this is probably my second favorite topic in electromagnetics, is that because there's a one-to-one relationship between all these quantities, we can actually apply uh, circuit analysis techniques like voltage division and current division and Ohm's law and Kirchhoff's law to solve magnetic systems like the magnetic flux in magnetic materials. And so this is really cool. So this is how we're going to finish our study of magnetic fields in materials with magnetic circuits and the forces that we can get in magnetic circuits. But first, let's start with um, the idea of magnetization. And remember, this is the dual to polarization for electric fields.